Welcome to another video by Team Matcom. In this particular video, we will be discussing a problem on the chapter Motion in a Straight Line in the class 11 NCERT plus 1 textbook. So the question is the speed time curve of a particle moving along a fixed direction, that means it is in motion in one straight line, is given below. Obtain the distance covered by the particle between time t is equal to 0 to 10 seconds and b and t is equal to 2 to 6 seconds. By seeing this particular question, you can understand that they have given you velocity versus time curve, velocity versus time curve. Since from the time 0 to 5, as well as from 5 to 10, the graph is in the two different directions. So basically, from 0 to 5, 0 to 5, the speed is getting increases with respect to time. From 5 to 10, the speed is getting decreases with respect to time. That means you can understand that from 0 to 5, speed is getting increased. That means it will be having a positive acceleration. It will be having a positive acceleration. Since the speed is getting reduced from 5 to 10, it will be having a negative acceleration. It will be having a negative acceleration. That is the concept you can understand. So they have given you a speed versus time curve. Since it is a straight line, when you're obtaining a speed versus time curve is a straight line, it is a uniformly accelerated body. So it is a uniformly accelerated body. Uniformly accelerated body. That means you will get a straight line curve. For a straight line curve, in the case of speed versus time, it is for a uniformly accelerated body. So when you're having the curve, straight line curve for a uniformly accelerated body, if you take the area under the curve, if you take the area under the speed time curve, area under speed time curve of a uniformly accelerated body, for a uniformly accelerated body, the area under the curve will give you the distance covered. Area under the curve will give you distance covered. We will solve this particular question both by using graphical method as well as by using the equations. First, we will see the graphical method. Since if you want to do it, we can just mark it up, this particular triangle. The curve was O, A, B, C. We are having two curves, but both are in the symmetrical. You can take it as a single curve itself, or if you can consider as two different triangles also. Okay, let me consider it. Let me consider it as two different triangles. Let me consider it as two different triangles. First one, triangle OCA, triangle OCA. Therefore, area of the triangle will be equal to what? Half into base. Base is OC into height is AC. So what is the value of OC? Value of OC is 5 seconds into AC is 12 meter per, because from 0 to speed is increased to 12. So 12 into 5 is 60 divided by 2, that is equal to 30. So that will be equal to 30. In the same way, if you consider triangle ACB, area of the triangle will be equal to half into base is BC into AC, Therefore, half into BC is 5 to 10. That means BC length will be equal to 5 into AC will be equal to again 12. 12 into 5 is 60 divided by 2 is 30 meter. Okay. So, for example, the total area. Therefore, total area will be equal to 30 plus 30 will be equal to 60 meter. So the 60 meter is the distance covered. 60 meter is the distance covered by this particular particle for the time being of 0 to 10 seconds. You can do it directly. How you can do it directly? You can take the area of the triangle ABC. If you take, so not ABC, area of the triangle AOC. If you find out the area, that is equal to half into what is the base? OB into what is the height? AC. That is equal to half into OB length will be equal to 10 into AC length is equal to 12. 120 divided by 2, that is equal to 60 meter. You can get the answer directly also. So this is the way in which the distance covered by the particle from t is equal to 0 to 10 second can be calculated directly from the graph, because for a uniformly accelerated body, the area under speed time curve will give you the distance covered. Will give you the distance covered. How can we do this? By using the equation. For example, you need to mark it as O, A, B, C. You need to consider this as two different conditions. For example, this is from t is equal to 0 to t is equal to 10, because that from t is equal to 0 to 5, it has a positive acceleration. From 5 to 10, it is a different acceleration. So we need to consider it as two different cases. That means from t is equal to 0 to t is equal to 5. See, at t is equal to 0, it is starting from the rest. Therefore, its initial velocity is equal to 0 meter per second. When it reaches 5 seconds, the speed got increased to 12. Therefore, the final velocity or the final speed is equal to 12 meter per second. What is the time taken? Time taken is equal to 5. So what would be the acceleration? Acceleration is equal to v minus u upon t. That is equal to 12 minus 0 divided by 5. Therefore, acceleration will be equal to 12 by 5 meter per second squared. Acceleration is 12 by 5 meter per second square. Now we can calculate, since it is a uniformly accelerated body, you can calculate the displacement or distance covered is equal to ut plus half at square. That is equal to u value is 0 into 5 plus half into acceleration is 12 by 5 into time square. Time is 5 into 5. 1 5 and 1 5 will get cancelled out. Remaining we have 12 into 5 is 60 divided by 2 is equal to 30 meter. Will be equal to 30 meter. In the same way, from t is equal to 5 to t is equal to 10. At t is equal to 5, its initial velocity is 12 meter per second. Therefore, initial speed is equal to 12 meter per second. It is coming to rest at the 10th second. Therefore, final velocity is equal to 0 meter per second. Time taken is equal to 5 seconds, because from t is equal to 5 to t is equal to 10, 5 seconds. Therefore, acceleration is equal to v minus u upon t. That is 0 minus 12 divided by 5, that is equal to minus 12 by 5. So acceleration is minus 12 by 5. Therefore, s is equal to ut plus half at square. What is the value of u? It is 12 into time is 5 plus half into at square. Acceleration is a minus 12 by 5 into t square, that is 5 into 5. 1 5 and 5 will get cancelled. Remaining 12 into 5 is 60 plus 1 by 2 and 12 cancel, you will get 6 here. 5 into 6 is equal to minus 30. So 60 minus 30 equal to 30 meter. So if this is S1 and this is S2, so the total distance covered is equal to S1 plus S2, that is 30 plus 30 equal to 60 meter. This is the way in which you can calculate it by using the equation. So what about the second part? We need to calculate from t is equal to 2 to t is equal to 6 seconds. T is equal to 2 to t is equal to 6 seconds. That is in a two different acceleration condition. That is t is equal to 2 to t is equal to 6. Two different acceleration condition. That is t is equal to 2 to t is equal to 5. And t is equal to 5 to t is equal to 6. T is equal to 5 to t is equal to 6. So we know that from t is equal to 2 to 5, the acceleration is 12 by 5. Therefore, acceleration is 12 by 5. Here the acceleration is minus 12 by 5. Minus 12 by 5. So we will take the first condition. From t is equal to 2 to t is equal to 5. We need to find out the velocity in each case. Therefore, the velocity or the speed at the time 2, that is equal to u plus at. So what is a u? Here at the time 2, it is starting from rest. Therefore, 0 plus acceleration is 12 by 5 into at what time you are calculating? At the time of the second. That is equal to 24 divided by 5. So the velocity at the 5th second, that is equal to u plus at. Its initial velocity is 0 plus acceleration is 12 by 5 into 5. 5 and 5 cancel, you will get 12. Therefore, the velocity of the particle at second equal to 24 by 5, 5th second equal to 12. There is no need to calculate because already it is given. Now, what we need, There is no requirement for this also. We need to calculate how much distance it covered from time t is equal to 0 to time is equal to t is equal to 5. Therefore, what is the netted time? Netted time is 5 minus 2, that is equal to 4 during the duration of 3 seconds. Therefore, S is equal to ut plus half at square. Here you need to understand one important aspect. From t is equal to 2 to t is equal to 5, its initial position is at t is equal to 2 and its final position is at t is equal to 5. So what is initial velocity? Initial velocity is nothing but velocity at the time equal to 2. Therefore, 24 divided by 5 into time taken is 3 seconds plus half into acceleration is 12 by 5 into time taken is 3 seconds into 3 into 3. Okay, this particular 2 and 12 can cancel, you will get 6 here. Therefore, 24 into 3. 24 into 3 is 72 divided by 5 plus 6 into 3 is 18. 18 into 3. 18 into 3 will be 18 into 2 will be equal to 36. 36 into plus 18 will be equal to 54. 54 divided by 5. So what will you get? You will be getting 72 plus 54. That is 75, like 7 plus 5 is 120. Therefore, 126 divided by 5. 126 divided by 5. In the same way, we need to calculate from t is equal to 2 to, sorry, t is equal to 5 to t is equal to 6. Acceleration is minus 12 by 5. What is its initial velocity? At v is equal to 5, that is already we calculated it as 12. Now we can apply s is equal to ut plus half at square. What is initial velocity? 12. For how much time? 5 to 6 means 1 second plus half into acceleration is minus 12 by 5 into t square is 1 into 1. So this particular 2 and 12 cancel, you will get 6 here. Therefore, 12 minus 6 by 5, that is equal to 12 into 5 is equal to 60. 60 minus 6 will be equal to 54 divided by 5. 54 divided by 5. So this is S4 and this is S3. That means we got how much distance it covered from t is equal to 2 to 5 as well as from t is equal to 5 to 6. So what is the total distance? Total distance will be equal to S3 plus S4. That is 126 divided by 5 plus 54 divided by 5. So 126 plus 54, that will be equal to 180 divided by 5, that is equal to 36 meter. Therefore, the distance covered will be equal to 36 meter. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.